Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here is another video in calculus. I hope that you will learn from this on limits. So guess the value of the limit if it exists by evaluating the function at the given numbers correct to 6 decimal places. So limit of quantity x squared minus 2x over x squared minus x minus 2 as x approaches -1. And these are the values very far from -1, then very close to -1, either from the left or from the right of -1. So when x approaches -1, so we have -1.001, which is left of -1, and we have -0.999, which is just to the right of -1. And notice that the numerator x squared minus 2x -1 squared minus 2 times -1, though do not approach to 0, but the denominator -1 quantity square minus -1, so plus 2, minus 2, so this approaches 0. So this means that because the numerator has no x plus 1 as factor or does not approach 0, so we are sure, supposedly, that since only the denominator is approaching 0, the limit of this function does not exist. So we will verify that as we substitute these values here. So using your calculator, you just type quantity alpha x squared minus 2 alpha x all over quantity alpha x squared minus alpha x minus 2. Then press calculate at these values of x. So for the first one, it is definitely 0. Then at negative zero point 0.5, negative zero point 0.5 square minus 2 times negative zero point 0.5 over negative zero point 0.5 square minus negative zero point 0.5 minus 2. And that gives us negative 1, then negative zero point 0.9 quantity square minus 2 times negative zero point 0.9 all over negative zero point 0.9 quantity square minus negative zero point 0.9 minus 2, and that is negative 9. So there's a trend that it is increasing negatively. Then at negative zero point 0.95, so negative zero point 0.95 square minus 2 times negative zero point 0.95 all over negative zero point 0.95 square minus minus quantity negative zero point 0.95 minus 2, so it is negative 19. Then negative zero point 0.99, so quantity negative zero point 0.99 square minus 2 times negative zero point 0.99 all over quantity negative zero point 0.99 square minus quantity negative zero point 0.99 minus 2, so it is equal to negative 99. Then at negative zero point 0.999, so quantity negative zero point 0.999 quantity square minus 2 times quantity negative zero point 0.999 over quantity negative zero point 0.999 square minus quantity negative zero point 0.999 minus 2, so it is negative 999. Then at negative 2, just to the left, so negative 2 square minus 2 times negative zero point 0.2 over negative 2 square minus quantity negative 2 minus 2, it is equal to 2. Then at negative 1.5, negative 1.5 square minus 2 times negative 1.5 over quantity negative 1.5 square minus quantity negative 1.5 minus 2, it is 3. So it is positive at negative 1.1 square minus 2 times negative 1.1 over quantity negative 1.1 square minus negative 1.1 minus 2, it is equal to 11. Then negative 1.01 square minus 2 times negative 1.01 over negative 1.01 quantity square minus quantity negative 1.01 minus 2, it is equal to 101. Then finally at negative 1.01001, so negative 1.001 quantity square minus 2 times negative 1.001 all over negative over quantity negative 1.001 square minus quantity negative 1.001 minus 2, it is equal to 1001. Since the right hand limit negative 9999 is not equal to the left hand limit, which is 1001, as x approaches negative 1, so since left hand and right hand limits are not equal, then it is true that the limit does not exist. So the answer, no limit, or the limit does not exist. Then evaluate the limits. Limit as x approaches 1 of quantity x squared minus 1 over x squared plus 3x minus 4. Then number 2, x squared plus x minus 12 over 2x squared minus 7x plus 3. Limit as x approaches 3. And this part. By the way, if you want to anticipate the solution to these problems, if you don't want to listen, you just solve these problems by your own because you know the calculations already, then you can by pausing the video. So let me just explain for this part. So x approaches 1, the numerator is 1 square minus 1, it also approaches 0. The denominator as x approaches 1 is 1 square plus 3 times 1, 4 minus 4, it also approaches 0. Since both the numerator and the denominator approach 0, that means that there is a factor of x minus 1 because there is a root of 1. So factoring out the numerator, which is x plus 1 times x minus 1, and the denominator, because we are sure that there is x minus 1, the other factor will be x plus 4. So this will be limit of quantity x plus 1, x minus 1 over x plus 4 times x minus 1 as x approaches 1. So we can cancel x minus 1 because this factor is not 0, it only approaches 0 because x is not exactly 1. Then that remains limit of x plus 1 over x plus 4 as x approaches 1. So this time, as x approaches 1, both the numerator and the denominator do not approach 0, so it is now safe to substitute x very close to 1, and in fact we can substitute x is 1. So that would be 1 plus 1 over 1 plus 4, and it is equal to 2/5. Now with the calculator technique, all you have to do is evaluate left hand and right hand limits. So that is, I want you to assign x equals 0.9999 left side of 1 and right side of 1, 1.00001. And the left side and the right hand limit should be close or equal so that the limit exists and it is equal to 2/5. So let's check. So 0.9999 square minus 1 over 0.999 square plus 3 times 0.999 minus 4 using your calculator there. I suggest that you type quantity alpha x square minus 1 over alpha x square plus 3 alpha x minus 4. Then calculate at 0.99999. You'll get 0.399988, which is close to 2/5, which is 0.4. Then the right hand limit, substitute 1.0001. So press calculate again with your calculator. Then x is 1.001, or 3 zeros before 1. Then you will get 0.400120. So they are almost equal. Left hand and right hand limits are equal, therefore the limit exists and it is in fact equal to 2/5. Then we proceed to number 2. For number 2, As x approaches 3, 3 square is 9 plus 3, 12 minus 12. The numerator approaches 0. Then the denominator, 2 times 3 square, which is 18, minus 7 times 3, which is 21. So 18 minus 21, negative 3, plus 3 is approaching 0 also, the denominator. So that means both the numerator and the denominator have a common factor of x minus 3. So factors of the numerator would be x plus 4 times x minus 3, and in the denominator 2x plus 1, 2x minus 1 rather, and x minus 3. So limit as x approaches 3 of x squared plus x minus 12 over 2x squared minus 7 plus 3 is the same as limit of quantity x plus 4 times x minus 3 over 2x minus 1 and x minus 3. As I said, x minus 3 is common. Then we can cancel x minus 3 because when x approaches 3, this factor is not exactly 0. Remember the definition. It is only approaching 0, so we can cancel that. Then when x approaches 3, the numerator is no longer approaching 0, as well as the denominator. So it is now safe to substitute x is 3. So 3 plus 4 over 2 times 3 minus 1. So it is 7 over 5. So the limit is 7 over 5. Then if you want the calculator technique like what we did here, then you can. But that's the solution. Number 3, as x approaches negative 1, the numerator is 2 times negative 1 squared, which is 2 minus negative 1, so plus 3, minus 3, so the numerator approaches 0. The denominator, 3 times negative 1 squared is 3 plus 5 times negative 1, negative 2 plus 2. The denominator also approaches 0. So that means that the numerator and the denominator have a common factor of x plus 1. So that the root is negative 1. So the numerator should be factored into 2x minus 3 and x plus 1. The denominator should be factored into 3x plus 2 and x plus 1. So number 3, limit of quantity 2x squared minus x minus 3 over 3x squared plus 5x plus 2 is equal to limit of quantity 2x minus 3, then quantity x plus 1 over 3x plus 2 and x plus 1. Then we cancel x plus 1, and as x approaches negative 1, the numerator does not approach 0 anymore, and as well as the denominator. Therefore, we can now substitute x is negative 1. So that would be 2 times negative 1 minus 3 over 3 times negative 1 plus 2. The numerator is negative 5. The denominator is negative 1. So negative 5 over negative 1 is 5. Then number 4, as x approaches 4, 2 times 4 squared, 32, minus 7 times 4, which is minus 28, so 4 minus 4, the numerator approaches 0. The denominator is 4 squared, 16 minus 4 is 12, minus 12, the denominator also approaches 0. So that means there is a common factor of x minus 4 in the numerator as well as in the denominator. So the complete factored form of the numerator would be 2x plus 1 and x minus 4. The denominator would be x plus 3 and x minus 4. So we write number 4 as limit of, which is 2x squared minus 7x minus 4 over x squared minus x minus 12 as x approaches 4 into 2x plus 1, limit of quantity 2x plus 1 times x minus 4. Denominator would be x plus 3 times x minus 4 as x approaches 4. So we can cancel x minus 4. When x approaches 4, the numerator does not approach 0 as well as the denominator, so therefore it is safe to substitute x is 4. So 2 times 4 plus 1 over 4 plus 3, 9 over 7. So the limit is 9 over 7. So that's it for this video, and I hope that you can evaluate limits of any form by this technique and by simplifying using algebra, because the official solution to this would be this solution here. We have to find a way to factor it out, and then we simplify in such a way that uh, the both the numerator and the denominator do not approach 0 anymore. But if we cannot prevent it, just like in the first example here, then we just say the limit does not exist, or there's no limit. So that's it, and I hope that you learned something from this video.